Imagine a stone rolling off a cliff. Ever wonder how far it would go? Or even how objects in the first place move forward while also falling at the same time? Welcome back to LRC. In this lesson, we will be learning about vertical and horizontal motion, how they behave under uniformly accelerated motion, also known as UAM, and how to solve problems involving both. Vertical motion refers to the upward or downward movement of an object. One important thing about vertical motion is that its acceleration is mostly constant because of the force known as gravity. On Earth, this value is always set at negative 9.8 meters a second square, meaning objects will always accelerate at the same rate downwards in freefall. Freefall meaning the only force affecting this object is gravity. For example, when you drop an object, it will keep speeding up as it falls since gravity is continuously pulling it down. Horizontal motion, on the other hand, refers to the left or right movement of an object. Unlike vertical motion, horizontal motion is not affected by gravity. Instead, its acceleration depends on other forces such as applied force from a push, pull, or engines. For example, a rolling ball's speed is determined by the force of the push, while a moving car's speed is dependent on the force the engine gives off. These will be the terms and formulas we will be using. These are the basic kinematic formulas that we will be plugging in depending on the given that we are handed in the word problem. Please note that while both horizontal and vertical motion occur at the same time, they act independently, meaning that its components are solved individually and its variables do not overlap. For example, the velocity, initial velocity, final velocity, acceleration, and displacement for the vertical component are separate from the horizontal component. The exception to this rule is time, which is shared between both vertical component and the horizontal component. To start things off will be sample 1A. A stone is rolling down a hill at a constant horizontal speed of 10 meters a second. The hill abruptly ends 20 meters off the ground. Given this, how long does it take for the ball to hit the ground? To start things off, we should start by establishing the given. The given we know is that the ball started off at rest, so the stone had an initial velocity of 0 meters a second. In addition to that, we know the hill was 20 meters off the ground, meaning the displacement by the time it was at the bottom was negative 20. Also, the acceleration given gravity equals negative 9.8. The required here will be time. For the equation, we should use one of the basic kinematic equations. The one we'll be using is distance equals initial velocity multiplied by time added by acceleration multiplied by time square over 2. When we plug in the given, we get negative 20 equals 0 plus 9.8 t square over 2. Our answer now will be 4.08 equals t squared. And when we simplify that, we get 2.02 seconds equals time. Here we will be now solving for B. How much horizontal distance did the ball clear before it hit the ground? Here we will be solving for the horizontal component of the problem, meaning the things we used in the other problem and the values we have assigned to those variables, some of them will not apply here, so we have to establish the given again. The initial velocity for the horizontal component is 10 meters a second squared as seen in the problem. We also know that since this is a UAM problem, uniformly accelerated motion, acceleration equals 0 given in the name uniformly accelerated, meaning this is constant, meaning the rate of change is 0. The exception to the rule that vertical component or horizontal component have different values is time, which is shared between the two. So, given in the other problem, we solve for the time, we know that the time is 2.02 seconds. Here we will be solving for distance. We will also be using the same kinematic equation as in the other equation. So we will do the same. D equals initial velocity multiplied by time plus acceleration multiplied by t squared over 2. Now we plug in the given into the equation. We will get D equals 20 multiplied by 2.02 plus 0 multiplied by 2.02 square over 2. When we simplify this, we will get d equals 40.4. So now we know that the distance covered horizontally was 40.4 meters. To end this lesson, we need to remember that vertical motion is affected by gravity, while horizontal motion is not. Both motions can be treated as UAM, as long as acceleration is constant. By using the right kinematic equation and identifying the given values first, solving motion problems becomes much easier. These concepts help us better understand things and how everyday objects move here in the real world. This can be seen in everyday situations like sports, transportation, and seeing how our objects move. We hope this episode was able to help you understand more about UAM, vertical, and horizontal motion. Thanks for watching and see you next time.